All right, this is the first, this is Unit 5, Topic 2, Applications of Matrices. We are first going to solve systems of matrices, we're going to solve systems of equations algebraically, and then we're going to go ahead and use matrices to do that. I could not get my thing to load correctly at home, so today's topic, again, is solving systems of equations with two variables by substitution and elimination. It is a topic that you covered in Algebra 1. This is just a reminder of how this works. So the warm-up, this is on page 1 of the packet. If you don't have the packet, you're just going to draw 3 different ways. Okay, let's actually pick a pen with color here. 3 different ways. And you're just going to be taking, if you don't have your packet, you're going to just do this on paper. 3 different ways, 2 lines can either intersect or not intersect. So first option is you've got 2 different lines and they're going to have one solution. So they intersect one time. You've got 2 lines that are parallel and they never intersect. So again, these are parallel lines. And when you have parallel lines, you have no solution. Get rid of that extra. Parallel lines have no solution. So this has one solution if they cross one time. And then you've got 2 different lines, and there are one on top of the other. So notice that it's drawn well. One's going to be on top of the other. And this is infinitely, so they intersect at each point, at every point. And that's where we have infinitely many solutions. So we're going to see scenarios, you're most often going to see things with one solution where the lines would cross if graphed once. You will occasionally see infinitely many. You will occasionally see parallel lines. So we'll get into those, but generally speaking, if you are solving a system, you're going to have a true statement like 4 equals 4 if you have parallel lines. You'll have like 0 equals 4, which is a false statement. Sorry, that's not true. I just reversed that. Let's stop that and redo. Okay. Parallel lines is no solution, right? Parallel lines is no solution. So that is where you're going to see like 0 equals 4. That's not equal to, and there would be no solution. So that's when the variables cancel out, or when you graph and see parallel lines. That's going to be no solution. If you have a true statement like 4 equals 4, or 3 equals 3, or 0 equals 0, then your solution is infinitely many solutions. That's true when your variable cancels out when you're solving, then you know you have a special case. And when you have a false statement, there's no solution to it. And when there's a true statement, it's infinitely many solutions. Okay, so on the next page of the packet, you probably don't have in your hands. It gives us a lot of problems to go ahead and solve. So I'll take you through some of these here. First problem here, solve the system x plus y equals 10, x minus y equals 12. So this is a problem I would do by, and they're calling this elimination, by the elimination method. The reason I do elimination method is that x's are lined up over x's, y's are over y's, and most specifically, the y's are already opposite each other. So that's the goal with elimination, is to get either the x's or the y's opposite each other, so that when we add the equations together, the y's cancel out. X plus x is 2x equaling 22. If I am talking too fast, you can keep rewinding, you can keep going back. So x is going to be equal to 11. And if you remember back from Algebra 1, once we have our one answer, plug into the opposite equation, either of those original equations, 11 plus y equals 10. So again, you're going to plug x equals 11 into one of the equations. I'm going to choose to plug in x plus y equals 10, and we solve. So this is a case where we have one solution, and that one solution is at 11, -1. Again, this should not be brand new to you. You did this in Algebra 1 extensively. Probably got ready for your ACTs or SATs with this as well. The second problem here, x plus 2y, again, if you don't have your packet, you're writing this down, don't just watch. So this is a case where I'm going to do this by substitution. Because I have substitution. Someone has already solved for our x variable. So we already know our x variable is x equals 8. So all I'm going to do is substitute x equals 8 into x in the opposite equation. And we have 8 plus 2y equaling -4. Subtract our 8. Divide by 2. And this is another case where these two lines, if you graph these two lines, they would cross one time at 8, -6. Third problem. Again, we're just seeing different types, and we're going to evaluate what's the easiest way to solve each one based on the information they give you. So this one has an equation that's in standard form and one that's solved for y, slope-intercept form. So when you have one solved for a variable like that, you don't want to undo someone's work unless you have to, unless someone tells you you have to solve this by a different method. So this is a case where I would do substitution. So we're going to take the y and what y represents, and we're going to replace what y represents in here instead of the opposite y. So this is going to be 4x plus what y would have been equaling 2. So y, again, is this 2x plus 5. There's nothing to distribute here, so you can drop the parentheses. If there were something to distribute, you would distribute if there were a number out in front. Like if this was 4x plus 3y, you'd distribute the 3. So we have 4x plus 2x, combined like terms. And we have 6x plus 5 equaling 2. 6x is equal to -3. And x is equal to -3/6, which is the same as -1/2. So, next step. We are going to go ahead and take that answer and plug it into the opposite equation. So y, we're going to take x equals -1/2 and plug that into y equals 2x plus 5. So this is going to be y equals 2 times -1/2. Then replace that x plus 5. This is y equals 2 times -1/2. 2 over 1 times -1/2 is -2/2, which is -1. And this is now a third case where we are looking at a single solution. These lines cross one time at -1/2 and at 4. The fourth problem here, 3x plus y equals 7. Make room here, didn't need to cross through that. And 6x plus 2y equals 14. Okay, so it's not solved for a variable, so I'm going to go ahead and use elimination. But before I can do elimination, if you remember this example, where are we? With elimination, the y's were already opposite each other. And you have to have them opposite each other in order to add them together to eliminate that variable. So we are looking to make either the x's or the y's opposite each other. So this is a +2 in front of this y. I want a -2 in front of this y. Or you can go ahead and do the same thing with the x's. And something very special happens on this problem. When I multiply through, again, the whole goal here is to, again, what you do to one, you have to do to all. -6x minus 2y equals -14. And now what I have is a very strange scenario. It's one of our special cases, because when I add these together, this cancels out, and this cancels out, and this cancels out, and I'm left with 0 equals 0. I mentioned to you again at the beginning of this lesson that when you have a special case and your variables cancel out, and that's a special case, you look to see, is this a true statement or a false statement? If it's true, then there are infinitely many solutions. That's what you have to say for the solution, because those lines are collinear, one on top of the other. If you took each of these, solved for y, it'd be the exact same equation for both. All right, on page 3 of the packet, if you happen to have the packet in front of you, you've got 4 more examples to make through here. Again, if you are good with this, go ahead and start the homework, which is on page 4, odds. Question number 5. let's talk about the greatest method for this. So as you look at this, nothing's solved for y, so we're going to use elimination. And okay, so you can either multiply this second equation by -1 or the second equation by 2. It just depends on whether you want to eliminate x or y. Let me just multiply this one by -1 just to start working on the x's. We've done a lot of work on the y's. I'm going to show you can get this answer either way. So negative x, or -1x, negative times negative y is positive y, equaling -1 times 3, -3. Okay, now elimination, you have to have one pair of these opposite each other. Cancels out the x's. 2y plus 1y is 3y, equaling 6. Y equals 2. Go back to any of the original equations, take y equals 2 and plug it in, x plus 2y, it doesn't matter which one you pick, and replace that y with the 2. X plus 2 times 2 is 9. And our solution is 5,2. Again, this is another case where these two lines are going to cross at one point. And that point that solves both equations is 5,2. All right, next one. X minus 2y equals 1. X equals -4y plus 7. Okay, again, I've already solved for one equation. It's already solved for x. So I would go ahead and do this one by substitution, if given a choice. So I'm going to replace x in this equation with this expression that represents the x. So I'm going to do this in parentheses first. It would be x minus 2y equals 1. We're going to replace the x with what x represents, which is -4y plus 7. There's nothing in front to distribute, so you can just drop those parentheses. When you combine like terms, we have -6y plus 7 equaling 1. Subtract our 7. Divide by -6. Sorry, ran out of room here. And y is going to be equal to 1. Go back to this equation that's already solved for x. That's the easier one to plug into. You can do either one. -4 times 1 plus 7. Again, so what am I doing? Let's get rid of that. What I'm doing is I'm taking y equals 1 and plug into x equals -4y plus 7. So x is going to be equal to -4 plus 7, which is 3. And 3, 1 is the ordered pair where these two lines cross each other. Again, if you're at the point where you're good with this, you can move on and start your homework. But here are the last two examples. Number 7, 2x plus 3y equals 6, and 2x plus y equals -2. Okay, we're going to use elimination because the x's, they're both in standard form. Let's go ahead and make the x's opposite each other here, because that's probably the least amount of work here. Multiply this equation by -1. I have my first equation, 2x plus 3y equaling 6. I distribute this negative to each term. -2x minus 1y or minus y equals negative times negative, which is +2. Again, elimination, you have to have one pair opposite each other. Our x's are, if 2y equals 8, divide by 2. And I have my y equals 4. Then go back to one of your original equations, it does not matter, and plug y equals 4 into 2x plus 3y equals 6. So 2x plus 3 times 4 is 6. When we subtract our 12 from each side, we get 2x equals -6. Divide by 2, and x is equal to -3. So -3, 4 is the solution. Last one, 8. Y equals -2x plus 8. And x equals, x minus 3y equals -3. So again, since I've already solved for a variable here, we're going to do this by substitution. unless they tell me to do a different method. If they tell you to do elimination, then all you have to do is to bring this 2x over to the left, negative 2x over the left side by adding it, and then it would be in standard form and you can do elimination. But if they have it in this format, it's easier to do by substitution. So it's x minus 3 times whatever y represents equals negative 3. And our y is represented by negative 2x plus 8. So we are going to distribute this negative 3, and it's going to be x, negative 3 times negative 2, which is positive 6x, negative 3 times positive 8, which is negative 24, equals negative 3. Add 24 to both sides. 7x equals 21. Then I have my x value of 3. Take x equals 3 and plug into one of the equations. The easier one is the one that's already solved for y. Plug it in here. Y is going to be equal to negative 2 times 3 plus 8. And our solution is at 3, 2. So you have seen 8 problems here, which is a good amount of problems that hopefully reminds you of what you did back in Algebra 1. So page 4 is your homework assignment. There's 3, 6, 9, 12 problems. You're only doing the odds, so you're doing 6 of these. So 41, 43, 45, 47, 49, and 51. So you will need that assignment for that. Let's see if I can pull this up so you can see it. Let me experiment here. No, I had the PDF. Yes, okay. This is helpful. So you are going to do the odds on this page. So if you want to, let's make this smaller. I'm going to just keep this here for a minute. No! Back. Oh. So here are the odd problems. You can take a picture of this with your phone, and you are going to see if you can make it a little bit bigger so you can see it. Okay. You're doing odds, 41, 43. Again, that's looking kind of small. So 41, 43, 45, 47, 49, and 51. So go ahead, if you don't have your packet, copy down those problems and do these problems on another sheet of paper. Rewind here. And that's your homework for tonight. Have a good day.